Alrighty, so we talked about the payoff amount is K plus 1 multiplied by R minus U. So let's start looking at finding the early payoff amount. And one of the methods we're going to look at is equatorial. So we're going to look at equatorial versus the Rule 78. So first, the equatorial method is suppose that you have a loan for 4 years with a monthly payment of 185 and an APR of 9%. The original finance amount is 1426. If you decide to pay off in 3 years rather than 4, find the uninterest and the payoff solution and the payoff amount. So we're going to use first the formula. U is equal to K times R H over 100 plus H. Well, first, K is the remaining months. So you had it in 4 years, which is 48 months, minus you paid it in 3 years, so that's 36 months. So the months remaining are 12. So K is going to be 12. R is the monthly payments. The original monthly payments are 185. Now to find H, you're going to have to use the APR. So you're going to use K, the number of payments left is 12, and your percent is 9%. So then there's the table. There's my 9%. There's my 12 months. So that aligns to 494. So H is 4.94. So to solve for my U, I'm going to use K, which is 12, times 185. Oops. Parentheses 4.94 over 100 plus 4.94. So I'm going to use my calculator, and when I plug it in, I should get 104.51. 104.51. That was the APR that we found given. This is the unearned interest. Now we still have to find the payoff. Oops. So the payoff is K plus 1, well, this is 12 plus 1 times R, which is 185, minus U. This is U. So let's punch this. This is 13 times 185 minus 104.51, and that is the payoff amount. So the payoff amount is 2,300.49 cents. This is the payoff amount. So we need to use the APR table to find H. That was the trick for that one. So here, there's the APR table. So you're going to use here for us, instead of this N, it's now going to be H. Sorry, let me change this. This is going to be now K, the remaining payments. The remaining payments. And then, of course, on the top will be that APR that will be given. Now, H is the finance charge per $100, which was $494. Okay. Now, what about the uninterest rule using the rule of 78? So the one that we did up top, so the top was equatorial method. Now we're going to look at the rule of 74. What's the difference between those two? So for a closed-end loan requiring monthly payments, which is paid off earlier than the schedule, let F, now there's another, let F be the original finance charge and the number of monthly payments originally scheduled, K, the remaining number of scheduled payments after the current payment. So now U is calculated in a different way. U is going to be K times K plus 1 over N plus 1 times F, where F is the original finance charge. So let's look at an example. Now we're going to do the same thing. We're going to use rule of 78 to compute the uninterest from the last example. So what did we know? Well, we know K was equal to 12. And well, now N is going to be 48. Why 48? What's the number of payments originally scheduled? N was 4 years, which is equivalent to 48 months. And then F, the amount was 1426. How did we go and get 1426? Let's look at the original, because that was the original financed amount. The original finance charge was 1426. So that is going to be my F. F is the original finance charge, which was 1426. So if we write this down, we're going to have our K to be 12, our N to be 48 months. Now we have a K times K plus 1, so 12 times 12 plus 1 over 48 times 48 plus 1, all times 1426, because this is F, the finance charge provided. So the difference is that for the equatorial, you use the APR. For the rule of 78, you don't have to use the APR. So then you get 94.58. Well, this one is less. So note that 9.93, because we had the end interest was 104.51 minus 94.58, the difference between those two is a 9.93. So note that this is $9.93 less than your savings by the equatorial method. Okay. So the rule 78 so the rule of 78 does not use the APR table, where on the first part, which was the equatorial, you do have to. Now, the fearless last slides talk about finance charge per $100 finance. So if an installment loan requires N equal monthly payments and the APR denotes the true annual interest rate of the loan, then H, the finance charge per finance, per $100 finance is calculated as a something different. So this one, the H will denote the APR when the APR denotes the true annual interest. So we're going to look at this formula, which is H is equal to N times the APR over 12 times 100, all over 1 minus 1 plus the APR over 12 to the negative N minus 100. So this would be the true H value, the finance charge per 100. So this is if the installment loan requires an equal monthly payments. So it depends on what question they're asking you. So we're going to do an example. So if a loan of an APR of 10%, they're already telling you what the APR is, 10% or 0.10, and stipulates 30 payments of $125.40 each. If the loan is paid off on the 18th payment, find the unearned interest and the payoff amount. Well, we're going to have to use this H as well and find the unearned interest. So there is the formula that we just learned. N times the APR, there's the APR right here, over 12 times 100. So the APR was 0.10. The 12 months, comes from the original monthly payments was 30, but you paid on the 18th month. So 30 minus 18 gives you 12. So that's why N is equal to 12. So then these will cancel. And I'm going to get 0.10 times 100 over 1 plus 0.10 over 12 to the negative 12. minus 100. So this you can place on your calculator. I also recommend you to use Wolfram Alpha when you're doing your homework. So let me go ahead. How does that look like in Wolfram Alpha? So let me go here. And then there's two ways. There's the natural language and the math input. You want to go where it says math input. So you're going to go and you're going to put in 12 and then, oops, parentheses, fraction. And then because it's 12 times, and then here I get 0.10, and then here down here I have a 12. And then this value times, oops, 100. And then I have a big division. So I'm going to put a bracket and a bracket. And then I put division. And my denominator is going to be 1 minus parentheses 1 plus, there's my fraction, 0.10 over 12. This value will be raised to the negative 12, negative n. All this is going to be subtracted by 100. And let's hit enter. And that solution should give me 5.50. So my solution should be 550. So that would be my new H. So next, use the equatorial formula to find the uninterest U. Well, remember, U for the equatorial was this top part, K times R H over 100 plus H. So there it is. K times R times H over 100 plus H. And we found what H was in the past. There's K. The remaining was 12 months. And it was $125.40. H was 540. That's what we found from the top part up here. And we found K to be the remaining number of payments, 30 minus 18. And then we use 550 over 100 plus 550, and we got a total of 78.45. Now, when you are doing the amount of interest where it was saved, this was K plus 1 times R minus U, the interest. So K plus 1 is 12 plus 1 times R minus what you just found on top. Using, again, this was using the equatorial. The equatorial formula. And we got 1,551.75. And that terminates this section. So this section was a lot about formulas. For the equatorial, we had to use the APR. However, when you already know what the APR is, and you already know it's going to be in equal repayments, then you're going to have to use this new formula for H, okay? Which stands for the finance charge per $100 finance, okay? And that's how we finish section 13.3. Thank you, and I will see you guys next time. Bye-bye.